All right. Good morning, everyone. So what I'd like to start with is, what's the difference? What's the difference between um, a 1 or a 2 on one roll of the dice and a 1 on one die, or a 2 on the other? Is it the same thing? So in this one, I've got one die, and I'm saying, what are the chances of getting a 1 or a 2? And on the second case, I've got two dice, and I'm saying, what are the chances I get this or this? So that was something that's going to be on your in the grade test. So good news is that I'm going to write your end of course test. Kind of amazing, right? You know, the state, for some reason, they don't have a standard test. So I'm going to write it. So I know what's on it. So that's really good. But the bad thing is that I have to try and cover all the standards. So it's kind of a long test. So this is one of the things that you have to understand. So take a look at this and think to yourself. So this was on that section of the test that I had. And so this one isn't so bad. So this one is really saying what? It's saying that two out of the six results are ones that I care about, right? But yes, sorry. Yeah, I did that twice, done that twice in a row now. Okay, so what are the chances of 1 or 2 on a roll of the dice? 1 or 2. You can kind of add them up, right? Well, it's a sixth and a sixth. We had a problem on the test that was more a dice or an ace, right? But let's just stick to two dice. What are the chances that you roll the dice and you get either a 1 or a 2? Well, first off, you have this problem. What does or mean? Okay. What does or mean? Okay. In other words, does or mean this? To get a 1 and a not 2, or a not 2 and what do we do? No, a not 1 and a 2. In other words, is it saying I get this, or do you also accept a roll where you get both? Do you accept a roll where you get both? I think that most of you would agree that in human language, if I say, what are my chances of rolling a 1 or a 2, you would also accept getting a 1 and a 2. You would say that. If you don't, so in computer science, usually it's very often the opposite, right? And they call that, well, they call it an exclusive or. It has to be one or the other, but not both. Not both. So it's not, maybe it wasn't even clear in that. So I might have to improve the question about that, right? And so it was throwing a 1 or getting an ace. What are your chances? But let's assume that this is what we want. We want 1 or 2 or both. Okay, so see if you can write it down. What do you think it is? So let's do a little calculation and see what you get. And I'll show you, I think, two ways I think you could calculate it. So what are your chances of getting, you have two dice, so you're going to roll, you roll them both at the same time. What are the chances that the first one has a 1 or the second one has a 2, or the first one has a 1, and the second one has a 2. So, and let me put the chat in here, and chat to me when you've got the answer. And I'm going to write out what I think it is. So I think it is okay. So if you're not sure what to do, one way to do it is, what are the chances of getting a 1 and not a 2? So your chances of getting any particular thing are 1 out of 6. What are your chances of not getting a 2? 5 out of 6. So you multiply those together. Okay. So the chance that you'll get, when you roll 2 dice, a 1 and not a 2 are 5, 6. And it's the same for the second die. Your chances of rolling the 2 are 1, 6. The chance that the first one wasn't a 1 are 5 out of 6. So you say, okay, there it is, 5, 6. But then we're saying, well, we'll also count it of rolling a 1 or a 2 if you get both. And what's the chance of any given combination, like a 1 and then a 2, is 1 out of 36, right? 1, 6 times 1, 6. What's the simpler way of doing it? So the simpler way of doing it is saying the complement of getting at least a 1 or 2 is getting neither a 1 or a 2 on the roll. And what are the chances of that? Well, 5 out of 6 chances you don't get the 1, and 5 out of 6 chances you don't get the 2 on the other die. So you multiply those together and subtract, and you see that you get 1136 for both. Okay. All right. So we'll go over that, but you have to learn that. You have to learn that for the end of grade. You have to be able to have those two things. And so it's hard because it's 3 separate things. It's the chances of one plus the chance of the other plus the chances of both, or subtracting the chances of neither. Okay. And so just to follow that up, 3 coins, at least 1 head. Okay. This is an example. That's complicated, right? So it's the chance. So 3 coins. How many chances do you have? You have 8, right? 2 to the 3rd power. So you say, okay, well, what are my chances of getting 3 heads, 2 heads, 1 head? What's the complement of this? So think about that. What's the complement? So the complement is no heads. Okay. So the chance of, and you're going to subtract, you're going to say 1 minus the probability of no heads equals the probability of at least 1. So you say, oh, well, I know that. So it's 1 minus 1/2 to the 3rd power equals 1 minus 1/8, 7/8. Okay. So that's a skill that you really have to have of how to do that. So then we were working on this idea of a dilation. And one that I looked at it and I was kind of thinking, so let's say you're trying to take a picture, right? And you've got, and you're standing here and you say, okay, here's the people in the frame. What happens to get the people in the frame, right? So what do you do? So you move further back, right? You move further back. So is the point of dilation, is it the center? And so I wasn't sure either, thinking about it's because what you're doing is you're trying to go back like this, right, to get a bigger amount. So I wasn't sure. To me, I wasn't clear if you're really, in a way, yeah, you're expanding the picture, but I think in a way it's more to do with going back like this. So you're changing the back. And then I posted, so they had a question about the rubber band. I didn't know what that was either. So the idea with the rubber band is that you have a knot. So the video shows it, is you have this knotted rubber band. So it's like 1, 2, 3. So you put the number 1 here, and then you kind of trace it and it expands it. So that probably only it's not like it's something that scientists do, but it's something you can do in a classroom to demonstrate, and that's what it was. And okay, so triangle dilations. So the thing about these dilations is that usually you can think about them more easily on a grid. Right? So you can think about them more easily being on a coordinate plane. And the nice thing about being on the coordinate plane is then you can, so let's say that you have a little triangle here. And you're down, yeah, like down 2/3. Okay. So let's say you've got this triangle here. And you want this to be your center of dilation. And you want to have a dilation factor of 3. So when it's on a grid, the nice thing is you say, I'm just going to divide it up into my X and Y components. So I say, well, if right now my Y, so this point is down 2, so now it's going to be what? It's going to be, if I'm going to triple it, let's say we're going to triple it, what's going to happen, right? Is you're going to triple how far away you are. So I was down 2, now I'm going to be down 6. Okay, so you say, okay, I'm going to be down 6, 2, 3, 4, 5, 6, 2, 4, 6. So I'm going to be all the way down here. And it's 3 to my right, so now it's going to be 9 to my right. So 1, 2, 3. So it's going to be down here. So that point is going to be all the way over here. So I'm tripling it away. And this point also is going to be. So that's I think something that you'll notice is that it makes more sense to do these on a coordinate plane when you get them. And that's what I was seeing on the tests as well, is that you're going to do it that way. Let's get rid of this guy. Oops, look at that. Okay, so the way this this mathematics vision project, we're going to try working on these for a while. Okay, so I think we're going to use this first one twice. There we go. So let's try these exercises. Given triangle ABC, use M as the center of dilation to locate the vertices that are 3 times longer. Okay, so as I say, it's not quite as easy when you're on this. So you're going to say, you're going to say, okay, it's 3 times further away. So you're going to do triple that. let's just try if we can get A and B. So we say, okay, whatever we had A, so we're going to go down 3 over 3. So A is like over here, and B is like triple that. So maybe get something like that. Now use N as to make it 1/2. So then make N from here. So I guess we're going to take half of this. So we say, okay, A, B. So it'll be half of that. I guess if you had a ruler, I could measure them. Too lazy to do that. All right, so okay, so let's see, what do we know about proportionality? Okay, so let's try this. Let's say we started with ABC, and then we did DEF was triple. And then GHI was a half, a tiny one. 1/2 of original. And so what's going on here is you think about AOPS, and AOPS had a kind of geometric construction of similar triangles. And we had all those theorems about how you could prove they're equal and stuff. And what you find in Common Core is that people don't care about geometry anymore. And so this is really trying to link similar triangles to the idea of algebra. You know, we're multiplying everything by 3, or we're dividing by 2. And so maybe the first insight that you need is, what's the relationship of DEF to GHI? Okay. So if you have DEF and you have this tiny little GHI, they're in proportion, but what's the proportion? What's the proportion between that? And so you could kind of say it like this, right? So this is, we're going this way, it's times 3. And this way it's times 2. So if you're times 3 and times 2, you should be times 6 altogether, right? So the side should be 6 times longer. Question for you though, so if you have that relationship, what's the relationship of the areas? Of areas of the smallest versus the largest. Right, so if the one got dilated by 3 and the other's half as big, the sides, what's true of the area? Okay, so remember, the triangle's area is in 2 dimensions, so it should be a difference of 36 times the area. So the other thing is that if you use a center of dilation that's A, what happens then? Is A still part of the dilated triangle? It is, right? And so then you get something that looks a lot more like what we were seeing in AOPS, is you get triangles that look like our similar triangles from AOPS, where you get the parallel lines, right? So these lines should be parallel to each other. Why is that? Okay. Why is that? So remember, that's that idea of side angle side. So these sides should be in proportion and they have the same angle. So this is more like the traditional geometry that we had, is you have a dilation, and so you don't even call it that, you just say you have those two triangles. Oh, well, there's something you can try and prove. Yeah, so that goes back, it's a different view of, it's a different way of looking. So let's see if we can figure out what this means. The segment joining the mid-set points of a triangle is parallel to the third side and half the length, okay? And so whenever you have to prove something, what's the easiest triangle to use? Probably a right triangle, right? So let's use a right triangle. Okay, so what are they saying there? The segment joining the midpoints of the two sides. So we say, okay, here's the midpoint, and here's the midpoint. It's parallel. So are they parallel? Okay. And is this length, is the relationship between these two also half? So we know that if this is a midpoint, then by definition, this is it's a 1-to-2 relationship, a 1-to-2 relationship. So is this a 1-to-2 relationship? And you can make the argument with similar triangles, I guess, as well. Okay, so your assignment then is just a worksheet that goes with this, but I wanted to get in one more thing about probability before we did it. Okay. So on your sheet of paper, in your notebook, please write down Pascal's triangle. So the second row is when you have a coin. So you have heads or tails, right? The third row is when you have two coins. So you have heads, you have two heads, heads, tails, two tails, okay? So that third row is what happens when I flip two coins, and it gives you the possibilities. What's your next row of Pascal's triangle? 1, 3, 3, 1. How much does that add up to? Okay, 8 total, which is 3 coins. 3 coins have 8 total. So what are your possibilities with 3 coins? Okay, so you have 1 times 3 heads. 3 times what? 2 heads, 1 tail. 3 times 1 head, 2 tails. And 1 times 3 tails. What's the next row? Okay, so build your next row. 1, 4, 6, 4, 1. Okay, that's throwing 4 coins. So what happens when you throw 4 coins? Okay, so there's 16 results. Okay. 1 out of 16 is 4 heads. 4 out of 16 is what? 3 heads, 1 tail. How often do you get 2 heads and 2 tails? 6 out of 16 is 2 heads, 2 tails. And then you notice how it's symmetrical. So 1 head, 3 tails is also 4 chances. Let's do the next row. Okay, so we add those up. We have 20 plus 10 plus 2, 32. So it's 2 to the 5th time. So when you throw 5 coins, what can happen? Well, you have a 1 in 32 chance of 5 heads, a 5 in 32 chance of 4 heads, 1 tail, a 10 in 32 chance of 3 heads, 2 tails, and also 10 in 32 chance of 2 tails, 3 heads, and so on. Okay. So the question you had on your test was, what about the 6th row? So what does the 6th row tell you when you throw 6 coins? What happens? So 1, 6, 15, 20, 15, 6, 1. Okay. So you have a 1 in 64 chance of 6 heads, a 6 in 64 chance of 5 heads, 1 tail, what's the 15? So you have 15 out of 64 chance of 4 heads and 2 tails. And then finally the 20, what's the 20? So the 20 out of 64, so about a third of the time, you'll get 3 heads and 3 tails. And you could keep going, right? So the next one will give you the chances of throwing 7 coins, and you should add up to 128. But this, if someone asks you, like I'm going to ask you on your final exam, something from Pascal's triangle, and that's what you can do. So make sure you feel familiar with this, right? And you can just work your way up from a head or a tail, 2 heads, head or tail, 2 tails, and all the way down. But you should feel good about doing that. Okay, so your homework is, so from now on, your homework won't be in the archive. It'll just be attached to the assignment. Huh. All right. So see you guys later.